Let us now try to graph a parabola that opens sideward. In the previous video, we were able to graph a parabola with the focus and directrix that is opening downward. And that is actually given to us already by the standard form of the given parabola or the equation of the given parabola. As for this parabola here, this is in the form y squared is equal to 4px. And if the variable with the second degree or the variable with exponent 2 is y, this parabola opens sideward. Now either to the right or to the left. The first thing that we could do here to graph this, because that's our concern, is of course we could decide first where is it opening to, so that we will be guided. The first thing we may notice here is the value of the coefficient here. So it's -6. It is a negative coefficient. Just by looking at that, we could decide that that parabola is opening towards the left because those are the areas where the values of x are negative. So just by with that, please be guided that it should open to the left. First thing to do here is to look for the vertex. Even if it's not needed here, we need to give the vertex first. The vertex for this standard form, because it doesn't have any pair here as to whether it has a given, by the way, this one, if it's x minus 2 or something like that, this is already given that the vertex is still at the origin 0, 0. So let's use this Cartesian plane here again. So we are going to have here our vertex at 0 and 0. Again, even if vertex is not asked, we could always be guided if we start with the vertex. Why? Because with the help of our understanding earlier that we have decided that it should open towards the left, we might be guided. There is already a guidance for us that it should look like this. Okay, and with that, if it looks like that, the focus could be in the interior of the parabola. So it's somewhere here, and the directrix is on the opposite side, somewhere here as well. Okay, but let's continue with the formal process to solve for our focus and directrix. The focus is to be achieved if we do have here the value for p. So again, this equation here is expressed as y squared is equal to 4px. Just by simple comparison, we might notice that -6 here is equivalent to 4p. This is -6 is equal to 4p. And then divide both sides by 4, you will get a value of p which is -3/2. Now, do not be confused with the previous video where p is also -3/2 because here we still also have -3/2. The purpose for this p is for telling us that the absolute value for this, which is 3/2, is the distance of the focus from the vertex as well as the distance of the directrix from the vertex. Now, since our parabola here is earlier decided to be opening sideward, we know that the focus is in the form of P0. Why? Because it is opening towards the left or the right, specifically here towards the left. So it should be the value of x that is changing, but not the value of y. Consider this. Take note that collinear po yung focus natin at yung vertex. Collinear, they lie on the same line. So they must lie here on this line here, and the focus should somewhere here. And if you pick any of these points that I have placed here, you might notice that these points here is where our x-axis changes its value, but the I mean the x-coordinate changes its value, but the y-coordinate did not because it's still 0. That is actually the reason why earlier it should be p 0. So our focus is at negative 3 halves the value for p and then paired with 0. By the way, if you're still confused with this summary, we do have that in our module, so please be guided. So this is our focus. We plot it here. Let's also again say that each of this grid is not 1, but let's say 1/2, so that we could ask this as negative 1 and this is our negative 2. So our focus is somewhere here. Sorry for that. Somewhere here. This is our focus at negative 3 halves and 0. This is support to our claim earlier, or not the claim, our analysis earlier that our parabola should open towards the left because again, focus is on the interior of the parabola. And if we're going to look at this is already the focus. So the graph should always look like this, containing the focus. Let's do it later. Okay, this is our focus. As for our directrix, let's have here our directrix is aligned with the same distance from the vertex to the focus. So if the distance here is 3 halves, so we could also ask here 1 and then 2. In here is where we could also locate our directrix here in this area, because this has the same distance but with the distance of vertex and the focus, and then distance of the vertex to the directrix. However, since our graph is now opening sidewards, we cannot make a horizontal directrix because it should be perpendicular to the axis of symmetry, which is in this case the x-axis. So the directrix is a vertical line now passing through that point with a distance from the vertex similar to the distance of the focus to the directrix, to the vertex. Sorry for that. Okay, I'm hoping this is straight. Yeah. So this is our directrix, and the equation for this, since it's a vertical line and it passes through x at 3 halves, so the equation for this is x at 3 halves. Mathematically, we can solve the directrix for this kind of standard form as x is equal to negative of p. Since p is negative 3 halves, that's negative of negative 3 halves. And then double negative property allows us to make the sign positive. X is equal to 3 halves. And this is our directrix. So here is our focus. Here's our directrix. Since we are asked to graph the parabola, and we are not asked to give other points yet, let's just assume that our parabola will look like this. Hopefully, it will somehow look like a parabola. That one. Let's just assume that it looks like that. Again, I cannot, based on what is asked, for the moment, let's try to consider this as what is our graph. So again, the graph contains the focus, or the focus is on the interior of the parabola, and the directrix is on the opposite side. This is how we graph parabola opening sidewards towards the left or to the right, which depends on the equation here. Use this together with the previous video to compare and analyze more examples of parabolas. Goodbye.